This is Elroy, feline in residence at the Gary and Rita Holton home. It's December 5th and a nippy 41 degrees outside. But by the contented look on Elroy's face, it's obvious the Holton home is comfortable. Yes, mighty comfortable, and there's a reason. You see, last summer, the Holtons decided to weatherize their home. To understand insulation, Gary and Rita found they had to relate to a new term, R value. The R stands for resistance. Heat is energy, and it's always moving from warm to cold. On a cold winter day, then, the heat in the home is trying to get out. And it will unless the house is insulated. Why? Well, because the insulation resists the escape of heat. And the resistance is measured in terms of R values. The higher the R value, the greater resistance to heat flow. Gary's overhead insulation was R11. Now, how did he know that? Well, he and a friend measured the cellulose fiber insulation already in the attic, and on the average, it was 3 inches deep. Cellulose fiber has an R value of R 3.8 per inch. 3 inches, then, is R11. You get that by multiplying the inches times the R value per inch. 3 inches by 3.8 equals 11.4. Or rounded off, it's R11. There are two other blown-in materials, rock wool and fiberglass. Rock wool has an R value of 2.8 per inch, and fiberglass is R 2.2 per inch. They're all good insulators, but you must know their R value. Gary was shooting for an R30 in his attic. A heat-holding R30 calls for 8 inches of cellulose fiber. It was simple arithmetic, then, to subtract the existing 3 inches in the attic from the total 8 inches to arrive at an additional 5 inches that Gary and Rita would have to blow in. Gary made sure the insulation he bought met local fire codes. The label contains all this information. Blowing insulation into an attic is a two-person job. Great for husband and wife teams. Rita feeds the blower, and Gary handles the business end of the hose in the attic. Insulation requirements vary across the country, so check with your utility, Department of Energy, Extension Service, or heat supplier for the necessary R value in your area. This whole process drew one interested observer, Elroy. Nobody said it was a clean job, and that's why Gary wears the face mask. And here's the finished job. A good 8 inches of cellulose fiber, which adds up to a reassuring R30. The Holtons used a 6-inch fiberglass bat for an R19 in their floors. This material is abrasive, so wearing a face mask and gloves, plus a long-sleeve shirt, is important. Gary's tools were few. With a sharp knife, measuring tape, stapling gun, and cutting board, he was well equipped to fence in escaping heat with a thick fiberglass barrier. Admittedly, Gary was fortunate to have a 4-foot crawl space under his house. Most homes have only 2 or 3 feet, sometimes as little as 18 inches. Gets a little cramped at times. Gary found insulating floors was basically a job of measuring, cutting, and fitting. Also helps to be fussy. You have to look for nooks and crannies that may expose floors to cold air. Gary's cutting board was simple enough, just a piece of lumber from the scrap pile, and his straight edge, a length of 1x4. Watch how Gary began this job, because this is important. He didn't just stick the blanket between the joists, but rather brought it up to the top of the end plate before stapling. That blocked off cold air coming through the plate from the outside. then on, Gary merely pushed the insulation into place, and the puffy fiberglass stayed put, temporarily at least. The fiberglass blanket wouldn't stay there long, though. Soon it would sag and fall down. So that's where a handy little item called tiger teeth came into play. Gary just bent the wire, the tiger teeth, between the beams, and that's all it took to hold the insulation in place permanently. There are several other suspension methods Gary could have used. He could have laced wire back and forth, or used a plastic mesh, or a heavy-gauge chicken wire. The motto here could be, don't squeeze the fiberglass. The more fluff the material has, the better it insulates. Squeezing insulation literally squashes out R-value. This R19 insulation should put to rest any problems the Holtons had with cold feet from cold floors. How do you insulate an exposed beam ceiling? With great difficulty has been the answer up until now. Gary and Rita, though, opted to use a new product, a fiberglass thermal ceiling panel. This furring strip anchors the panel to the one beam. Then the Holtons hoisted the fiberglass into position, and additional furring strips were nailed in to anchor it. Insulating a home saves energy and it saves money. But don't forget the comfort factor. Living is so much more comfortable in an insulated home. The thermal panel has a textured vinyl surface on its facing side. It's not a wood surface, but Gary and Rita still have the exposed beams, and their roof is insulated. Probably the simplest job Gary did was to turn down the two thermostats on his hot water heater. First, though, he turned off the power, and that's mighty important for personal safety. Gary turned his hot water heater down to 120 degrees. Then again, some people with dishwashers may prefer 140 degrees. A quick and easy turn of the screw does the job, from 155 degrees to 120. Then Gary wrapped the heater in a warm envelope of insulation. Like a tailor, Gary measured the size, then cut it to fit. It's kind of a baggy pants operation, though, because loose fitting, not tight fitting, is the name of the game when wrapping a water heater. There's a blue mark on the floor. It's in line with the thermostats. Gary put it there so he'll always know right where to locate them, even though they're covered by a thick layer of insulation. Gary would be lost without duct tape, but nothing does a better job of holding the pieces together. When finished, every square inch of the heater is covered. It's wrapped in an overcoat. With a gas or oil water heater, it's important not to cover the vent or chimney. One last major job was insulating the furnace cold air ducts. The material, beadboard. Each sheet is an inch thick and has an R5 value. Gary found a serrated knife was his best cutting tool. The mastic, the beadboard, all the insulating materials used by the Holtons in their weatherization campaign came from the local lumber yard. As Gary put this panel in place, you'll notice he held the beadboard already up there with strips of duct tape until the mastic dried. He removed that tape later. This insulation job looks great, and it certainly slows down heat loss. Well, that's how the Holtons did it. Their home is snug and comfy in the wintertime thanks to some definite action on the insulation front. Let's peek in on some others who are battling the spiraling costs of energy. A vapor barrier under a house is an absolute must. It doesn't insulate or weatherize, but it does just what its name implies, forms a barrier to keep the moisture from traveling upwards into the house. The ground under Rochelle Bagley's house appeared dry, but wisely she went right ahead with putting down a vapor barrier. Although the moisture can't be seen, it moves upwards as a vapor, increasing moisture in the home atmosphere. The more moisture in the air, the more energy it takes to heat the air. Rochelle uses 4 mil black visqueen, which works fine since the visqueen is not exposed to damaging sunlight. Clear visqueen would work well too. It doesn't hurt to stay in touch with local codes since some areas require 6 mil visqueen. The object here is continuous coverage. Where joints are required, the visqueen is overlapped a good 6 inches. To be sure she gets the maximum benefit, Rochelle taped the joints. She could have used rocks or sticks to hold the joints from slipping. She again used duct tape to seal around the posts. Well, how about wood frame storm windows? We caught Jerry Bieberly in the act of making some for his house. Again, it's not difficult. One caution, though. For the required snug fit, Jerry did take precise window measurements. It's always a boost to have a helper like Arnold Petrie. Let's face it, though, a helper like Bentley the dog, you don't need. Wood joiners clamp the boards together. Jerry will glaze the wood frames with transparent 8 mil vinyl. He double-checked when buying it that it had an ultraviolet inhibitor. This keeps it from breaking down in the sunlight. Now, this material will last for years. A 4 mil visqueen is cheaper, but it can deteriorate in less than a year. Just does not have the lasting power. The window can be held in place by nails or by a turn button. Any method of securing the window is fine as long as you can take the storm window off in the spring for reuse year after year. Heating ducts that run through the unheated parts of a house, such as an attic, garage, or basement, should be insulated. Unless they're insulated, they can waste more heat than they deliver. Basically, then, you're paying for more heat than you're getting, and that is no good. Insulating pipes and ducts can cut down on the annual heating cost by as much as 10%. Judy Bieberly uses a system similar to Gary Holton's water heater wrapping. The same 3-inch R11 batting is wrapped loosely around the duct and held in place temporarily with duct tape. Just to be sure the tape doesn't loosen, Judy uses a light gauge wire to secure the wrap. Sharon Krause zeroed in on the windows. She took them out of the casing so she could really get at them. She chipped out all the old putty. Dried out material that chips that easily may somehow hold the glass in place, but certainly won't hold heat in or cold out. As you can see, Sharon just wailed away with her putty knife. Still, she was careful not to crack the glass. To condition the wood, Sharon swabbed it with linseed oil. It's a way of putting oils back into the wood. Then it's new glazing compound, and the windows are spruced up and ready for the winter ahead. The escape of heat through these windows has virtually been cut off. These cracks and joints may not seem important, but they combine to raise heating costs and cause chilly drafts. Notice how Sharon kneads the compound in one hand and applies with the other. Think about this. In a newly constructed home, if all the cracks, crannies, holes, and gaps that allow heat to escape were put together, you'd have a hole that you could throw a basketball through. One of the most cost-effective things a person can do is caulk all the cracks, joints, holes, and any other little bitty crevices you can find. This includes around the frames of windows and doors, at corners where sides join, along the top of the foundation where the wood frame meets the masonry, and where pipes and wires enter the structure. What kind of caulking compound? Acrylic latex caulk does a great job. It lasts well, especially better than oil-based caulk, which dries up and falls out. Butyl caulk performs nicely at points where there may be movement, such as around pipes and wires. It has an elastic quality. Caulking is one of the most cost-effective things you can do to weatherize. May not save the most total energy, but research has shown that it's at the top of the list in paying for itself in energy savings, normally within the first year. Back to the Holton home, let's see what weatherization did for them. Energy savings? You bet. Floor insulation dropped annual kilowatt-hour losses by a whopping 2,413. Even Elroy got interested enough to inspect this job. Ceiling insulation, both blow-in and thermal panel, yielded a total 1,920 annual kilowatt-hour savings. So it's cold December outside, but there's no way you can call Elroy a cool cat. No, sir, you're looking at a warm, comfortable cat. Even if you don't have an Elroy in your life, weatherize your home to conserve energy, to save money, and to increase comfort.